Okay, let's talk a little about feature models and dimensions. This is a proof of concepts. By the way, if you want to make some question with proxy hands, 65L0 is the code for that. This is first disclaimer, this is a working prototype, so prototype quality. Let's talk a little about feature models. I'm sure this audience already know about feature models. There are quite a lot of in use in aerospace and other industries. So we want to review how we can improve how we work with feature models. So let's talk about a domain, for example, aerospace, right? Let's suppose we are interested to build in one piece of satellite like this one. So probably we will bound it to some physical constraints like cost, size, areas, you name it, right? So working in that way, we can start looking at the meta models we use for feature models, right? We start with a system and we can start decomposing that in features, right? Keep going and assigning property values and values that we want to capture for different costs of pieces or dimensions. But also we have at the same time subdivide feature in subfeatures and keep going on with the tree like, okay? Of course, depending on the feature model, some features are optional, some others are compulsory, so you have to deal with some constraint there, okay? And of course, we will define the properties at the higher level. And for example, we will have to assign a specific semantic to this property. Let's talk about cost. Cost is measured in euros, for example, and we will be aggregating that as the sum of all cost. Okay, it's not always the same case. And of course, we need to check that the types used for the properties are the one we use when we assign values. Okay, this is a very simple model. And this is something we can model, for example, with Essential. Essential is a tool we have to describe ontologies, data structures. At the end, when you can build this kind of models. Let me show you quite fast demos. I would like to do live demos. So sometimes it's complicated due to connectivity issues, but we are lucky, okay? So basically on the left, I'm going to open a demo feature models, this one. This is just an essential model for what I showed you before. Here we have the system. The system has a set of properties here, features, and here you have the definition of the feature and go on. So whenever you are going to save this, we can have a textual representation in Essential, but we also can bridge with other tools like EMF Core, used in the Eclipse Modeling Foundation world, or JSON Schema, that is quite popular, and we can incorporate other tools working with ontologies, right? So we can do import and export to other tools. Also, at the same time, we can we have on the left side, on the white part, an editor for that. So we can instantiate here our model and put the system and then add in feature one by one. Okay, the editor is just by default automatically generated on the fly, but you can start testing your real data modeling and start building on top of it. Okay, so with this in mind, we started with this prototype of the core feature model we want to build, and then have a definition for it, evolve it, prototype it, and then later on, if you need, you can generate code to a database, to any language you want. Okay. So about the semantic aggregation, I was explaining that, for example, cost or weight is something you will make assume most of the time, right? To get the full aggregation. It's not always the case. For example, if you are going to cross under a bridge, you want to know probably the maximum height, right? To know if your truck is able to pass below it or not. The same for minimum or for the count. If you are looking for redundancy systems, you are looking always to have at least 2 systems or 3 operating at the same time. So you need to fulfill some constraints on top of that. So let me put you another example. This is a textual example to configure a car. Everyone that's going to buy a car, sooner or later, they allow you to pick at least the color, right? So here you can depict how have different choices, and you have to pick one. This is the XOR, exclusive OR, and then you can put, if you want, air conditioning in your car. Of course, this will add some cost and some extra kilos, and any other dimension that you want to track bottom up from your system to build the final configuration for a specific car. So we have here different layers of design. First of all, you design the family of cars, the feature configuration of all the possible cars we are able to fabricate, to build, right? Later on, you instantiate this wizard to select your specific car. I want this car with red color, right? And this happens in many industries. Just quite briefly, this is for solar panels, residential solar panels. You can, depending on the size of your roof, you will put more or less panels, one inverter with one capacity or less, and you will put some optional batteries. So you can define all this system with a feature model that you can adapt to specific places for specific missions. This one is some real data from the website from PLD Space with Mura 5. And these guys in the next rocket, they have 3 configuration options to launch satellites. So at the end, you are modeling the properties of the different parts of the rockets, and you can pick to set up one extra large satellite, or 2 small, or 1 large and 4 very small. So you can adapt to check if your configuration is correct to have a proper mission, something doable, right? So traditionally, feature models are being used in space mission a lot. There is a central asset because you can assemble subsystem into bigger system with parts that are already tested from previous missions. So you can reuse a lot of assets and reduce cost and time because you already have an asset that is certified to fly, right? So it is an important part for reuse here, right? And you can control the risk. You are going to change some part to change for a new technology. You can control how many bets or risks you want to take, right, with new things. Okay, let's go a little deeper on examples about three times of designing. Feature modeling time, when we design the family. Mission design time, when we decide what satellite to send to build, or what car do you want to buy. And finally, the operation time, okay? Okay, phase 1. Let's suppose we are going to design a family of satellites. So probably we start modeling the satellite will decompose in 3 subsystems. We will generate on source, sensors, and communications. And maybe you can choose here if you want to use solar panel or nuclear power engine for the satellite, right? For sensors, you can add some optional sensors, and you will pick more or less depending on what you need. And finally, you will have maybe 1 compulsory antenna for communications, for control, and maybe other antennas for other uses. Depending on the mission you want to build, you will be assembled more or less parts, okay? So we are modeling this with DSLs, and we have a textual version, projectional version, and graphical version. I will just show you an example in a moment. Depending on the use case and how the user needs to see the information, we are trying to put the easy way of presentation for the user. For example, graphical could be a good nice overview of the general and then going to the details. Okay, let me show you here live demo. Again, I will pass the URL at the end. So for future modeling, basically here we have a base, a model in memory. Could be JSON. Maybe I will need to do more zoom here. But let's suppose we have a projectional view, and we have a system called Hello Seville. Okay, so in a textual way, we are just projecting this just to say Hello Seville with a specific syntax, textual syntax we are going to use, right? And if we use JSON in memory, okay, we just created this. Okay, nothing complicated. But let's look at a sample. This is the car example I was showing before. So here we have the model in memory. We can project this to be a textual representation, and we can work with this. Sorry, I will zoom it a little. using parsing technology and model-to-text technology to generate from one side to the other. So here is the peak of all the features and all the dimensions we are interested in this case. Okay. We can use a projectional way of approach to this. So maybe users to edit can follow the system and the description, but also look at the properties or look at the feature here. And if we have a version of the car, you can decompose this to keep going on and to check that, okay, this is my condition, probably is going to cost me some money. So here you have all the properties attached to this specific feature. So this is a way you can explore the projectional way, the model. But in some cases, if the tree get too complicated, maybe this is not a good representation, so we can explore for others, right? So finally, in some cases, graphical makes total sense to have this. So this is the same model also in a graphical way. So we work, we have samples with this kind of diagramming tool, you know, it's called DAGA. So here, let me show you, let's filter this a little. Okay, so yes, we are looking here to the system itself and then a list of features. Later on, a feature can have some properties. Let's suppose that we want to add a new feature, so we just put a roof for our car, right? A roof with a description, whatever. So basically, we can connect the roof with the system itself, and when we come back to projectional, here is the roof. So we provide different projections of the model, but we can build the views for the user depending on the use case they are building to. So here is the roof back to the model. This is a small sample of how we can work with this model at design time. Okay. Okay, second phase. Let's talk now to mission design time. In this case, the relevant questions are: do we have the required sensors on board? Is the payload weight still valid? Or what is the color of the car you want to buy? Okay, so in these cases, let's go to demo here. We need to do an instantiation of our model, feature model. Okay, so let's keep going with the car. This is something simple for everyone. So this is the chassis, it's mandatory, and add some weight. Okay, nothing to select there. But on versions, here we have 3 versions. And the rule is that you can only pick one version. So if you pick 2, you will get errors, validation errors, of course, trivial ones, right? So let's skip to this one. Let's keep going and then pick whatever you need to. And maybe we will need to decide the size of the wells. Again, if you pick too much, maybe you see the extra weight of the car, or you can only pick one type of wheels for sure. So when you have a valid configuration, you will automatic instant feedback. That is good for the designer to know if are we modeling in a proper way, or are we committing errors and pass unnoticed. So the fastest you can provide the feedback, the better. You will avoid errors. Okay, so we build tools. In this case, it's a projectional editor that allow you to select a configuration and check if everything is okay for the objectives that you want to achieve in this case. Okay, finally, we arrive to the third phase. The third phase is operation time, okay? Let's suppose that we buy that card or put a satellite. At the end, it's the same thing, more or less, because in the model world, in the future, everything has telemetry. You want to know where is your car, you want to know where is the satellite. Okay, so this satellite is going to provide, use solar panels. Probably you will need to track in real time that the power generation is what we expect. No? Or if there is any fault, we need to know, and maybe to reorient the satellite to get a better position for the lighting, right? So in these cases, all these models we already have are useful to build the ground control system, to build digital twins, to connect the telemetry of all the features to what we have in a digital twin, basically to control that everything is okay. And if something needs to have been adjusted, then you have the system on ground control system to send commands to fix what is possible or to change some what you can change, right? Okay, that's all. Let's go to the conclusions. So feature modelings are a good way to apply to a lot of domains. We have shown 3 of them. They are a traditional model used a lot in space missions, for sure. And we need, as Marcel was commented, better usability, better tools to work with all this stuff, right? And we need better traceability from requirements to operation. Maybe the digital twins here can help a lot. So basically, with requirements, you can trace back to feature models. Feature models create components, entities, and systems that you can, at the end, put in an embarked system, like the software that Pablo explained before, Pablo and his colleague. And each of these systems could generate telemetry, for sure, to check that everything is okay. The telemetry got delivered at the digital twin, and then, based on the data, you can decide to send command back to change how the system is working in operation. Okay, so we can reuse systems as commented before from previous systems, and this is a way that allows to save, incorporate new technologies. Let's suppose you have new motors or new engines you want to test. Maybe you can put more load in the rocket just because now you can put more, get more power and then have more payload there. Okay, so that's all. Thank you.
Yes, thank you very much. You're very good in time, so we have time for plenty of questions. So, other questions? Yes, please.
I've noticed that this model allows to express three-like relations of factors, right? So is it possible to express other relations between components? Like, for example, an engine can be repaired by this machine, but not that machine.
Yes. We here show a example, a small model. Yes, keep it small just for the sake of being able to explain it in 20 minutes. But yes, if you model more complex models with more complex relations, you can keep going down and express what you need. Here the limit is the expressiveness of the meta modeling layer, right? And if not, you can always go implementation part and then implement in code directly whatever validation rule you need to. Then on the modeling tool, then you fire all the validation rules and then try to provide feedback as soon as possible. Yeah.
Okay.
Looks like a very nice language for feature modeling. From language engineering point of view, what is behind?
Oh yes, well, this is the own technology that we generate at MetaDev. We try to do everything on the web, as you have seen. All of this is TypeScript. We have parsing in TypeScript, projection editors, and also the library, the graphical library you saw there is Daga. So with all of these things, we can build low-code, no-code tooling on the web, but also for secure systems like defense and things like that. Maybe you cannot use SaaS application, so you can put that on-prem in a container. Or so TypeScript gives you a lot of flexibility to put your modeling, meta modeling library in all the places that you need to.
So a remark and a question. So the remark is related to my talk this morning, where I introduced this technical memorandum TM1025, which is our system engineering information model, our ontology. And the way you do the breakdown is exactly as we do in that one. So I think it would be a very nice exercise to see how your tool could actually be matched with our ontology to see if we can speed up the modeling effort. Because the Comet tool we use is a highly dedicated solution that is not very convenient for end users to use, and I can see the immediate benefit of your approach there. The question is related to upcoming languages like SysML version 2. So I could also see that your solution could be a nice front end to do the same kind of modeling, because all concepts are there in SysML v2 as well. Are you planning to do that as well?
Yes, I like the question because the response is yes. We learn a lot in the Bergen meeting that when I meet you, about SysML, how big SysML version 2 is going to be in the space industry. And mainly the specification put a lot of effort on the textual side, right? But there is also a graphical one to be able to edit some part graphically or to change in the way you edit this kind of specification. The response is yes. We want to take a look further to the specification and check if we can put our modeling stuff to build tools that help in this area, because we know that SysML version 2 is going to be big. A lot of industries are going to converge to this standard, right?
Yes, please.
Nico?
On the topic of usable interfaces, it looks very nice. It makes sense to me. Seemingly also to you. Did you validate this with some actual users in these domains?
Well, in this case, this is very experimental, so no time for doing that. But in other talks, for example, in Orca, this is a more mature tool we already have. Another one my colleagues will show today later. We have started doing field research, user tested and getting feedback. So far, people used to love graphical views. So especially the non-coding people prefer graphical, for sure. When you arrive to programmers, you always want to copy and paste, and you will be more familiar with test. So maybe if you can, why not sacrifice any of the two? Provide both of them and provide automatic synchronization. If you can't, it depends on the domain, of course. But depending of the group of users, probably ones work better than others. So coders prefers textual. Experts, let's say expert or citizen developers prefers graphical. Yeah.
So I have a question related to this one, because when you maintain the same model but you have different projections, we found out that sometimes some information that is external to the model and specific for the projection is important, like spacing in the text.
Oh yes,
comments,
yes.
Or like where you place the nodes in a graphical, diagram. Maybe you arrange the information is the same.
Yes.
But for the user, it's meaningful.
Yes.
So do you store also this kind of?
Yes. And this is a good question. For sure, if you are coding, you will want to get spaces. It's for true. So we decorate the model. At the end, you decorate it. You provide an extensibility mechanism to preserve this information. Of course, the layout visually is quite important. Otherwise, the user don't relate what he was creating how long ago. So yes, the way is extensibility and keep it much information as possible if it's useful, and use it.
Okay, then let's thank the speaker again.
Thank you very much.